Hello students, in this lecture we'll see the explanation of formation of drops and bubbles. So basically liquid drops and small bubbles are spherical in shape, and the reason behind this is that the forces due to surface tension, they dominate the gravitational force. Now these forces, they always try to minimize the surface area of the liquid. Now a bubble or a drop, if you consider, it does not collapse, and the reason behind that is that the resultant of the external pressure as well as the force of the surface tension, the external pressure as well as the force of the surface tension is less than the pressure inside the bubble. So as these the resultant of these two is less than the pressure inside the bubble, it does not collapse. Now we can see this with an example. So consider this as the drop, and suppose this is a spherical drop and the pressure inside the drop is Pi and the pressure outside the drop is Po. Now as drop is spherical in shape, in the previous lecture as we have seen the variation in pressure outside that liquid and inside that liquid, as the drop is spherical in shape, the pressure inside the drop is greater than the pressure outside the drop. Now the excess pressure can be written as Pi minus Po, the excess pressure inside the drop. Now suppose the radius of the drop, initially it was r and then it increases by a small value delta r, that is final pressure is r plus delta r. Now as initial radius is r, then the initial surface area can be written as 4 pi r square and the final surface area can be written as 4 pi r plus delta r whole square. Now this r plus delta r whole square is r square plus, that is 2ab plus b square, as all of you know the identity a plus b whole square. Now expanding this, you will get this 4 pi r square plus 8 pi r delta r plus 4 pi delta r square. Now this delta r is very small, we have considered, so we can just neglect that quantity and the remaining you have is 4 pi r square into 8 pi r delta r. Now you have a1 and then you have a2. So the increase in surface area, it can be written as A2 minus A1 and you will get 8 pi r delta r. Now increase in surface area we have got. Now there is some work done while increasing this surface area, and the work done can be written as we have learnt in previous lecture, T into dA. So T is the tension here and 8 pi r delta r is the increase in area. Now from basic definition of work done, you know that it can be written as force into displacement. So here is F delta R. Now this force can be written as pressure into area. So you get final formula this. So you have one formula for work done and the other one. You can equate the both. Now if you equate the both, you will get this equation, and from that, cancelling the similar terms, you will get Pi minus P naught is equal to 2T by R. Now this equation gives the excess pressure inside the drop, and this is also called as the Laplace law of spherical membrane. Now if you consider a soap bubble, it has two surfaces. Now as it has two surfaces, the increase in the surface area will be multiplied by 2, that is 2 into 8 pi r dr delta r, and similarly you get this equation from the two formulas of work done, and excess pressure will be Pi minus P naught equal to 4T by R. So this is the excess pressure inside a soap bubble and this is excess pressure inside a liquid bubble. So this is all for this lecture. Thank you so much.